Welcome. This video is going to go over some paper 1 and paper 2 questions from chapter 9 on redox. So question number 1 wants to know what is the IUPAC name of Fe2O3. So you should realize it's iron oxide, and then you should realize you need to include the oxidation state for iron. And since it's O3, that's your hint that it is iron 3 oxide, or letter C. Question number 2 wants to know Question number 2 wants to know which species could be reduced to form NO2. So what you have to do is, first of all, you have to realize that the oxidation state for NO2, the N would be a +4, since there's 2 oxygen at -2 each. So that means you'd have to have nitrogen at an oxidation state higher than +4, like +5 or +6. So N2O would only be a +1 oxidation state, so that wouldn't be reduced, that would be oxidized. NO3, you've got a -6 from the oxygen, but you want to keep a -1 charge. That would put nitrogen at a +5, so B appears to be the correct choice. But let's just check. HNO2, that would put N at a +3. So that, along with the +1 for hydrogen, it would balance the -4. And D, it would put nitrogen at a +2. So B is the only one that would allow nitrogen to be reduced. Number 3 says, what is the reducing agent in this reaction? So what you're really looking for is what species is being oxidized. Now remember, it'd have to be something from the reactant side. So Cu2 plus is a product. The other 3 are all reactants, but Cu2 plus we can eliminate right away because it is one of the products. So then if we look at the other, Cu starts out at 0, and it picks up a +2 charge, so it's being oxidized, so this would appear to be the right choice. NO3 minus, you've got nitrogen going from a +5 to over here a +2 state, so it's being reduced, not being a reducing agent. And H plus is remaining unchanged, so A indeed seems to be our best choice. Number 4, which species is oxidized in the following reaction? So I've got silver going from +1 to 0. At the same time, I have copper going from 0 to +2. So the species being oxidized is the one that loses electrons, so that would be the copper, and not the copper ion, but the copper metal, the one that started on the reactant side. Question number 5 says, consider the following reactions of 3 unknown metals. So for each one, they start out giving you a metal ion, or metal nitrate solution, and then it's reacting with a solid metal. And in the first one, Y is the solid metal, and it is able to bump the X off, so that means Y is more reactive than X. In the second equation, Z is the solid metal, and it is not able to bump Y off, so Y is also more reactive than Z. However, when you put Z and X together, Z metal is able to bump off X, so Z is more reactive than X. So that lets me know Y is the most reactive, Z is second, and X is the least reactive, or if you write it in the opposite order, X is less reactive than Z is less reactive than Y, or letter B. Number 6 wants to know which statement is correct about the value of your standard electrode potential. What you have to remember is the more negative that your E value is, that's a more reactive metal. And more reactive metals tend to lose electrons or are oxidized. So the more positive, the less reactive metal, and the more likely that that metal will end up being reduced, or that ion will end up being reduced. So A and B are very similar. One says the more positive the value of E standard, the greater the driving force for reduction, and B says the more negative, the greater the driving force for reduction. Well, we just said the more negative, it's more reactive and more likely to be oxidized. The more positive is more likely to be reduced. And C and D try and make a connection between your electrode standard potential and the rate of reaction, which there is not one. Moving on to number 7 then, consider the overall reaction taking place in a voltaic cell. What is the role of zinc in the cell? So zinc is going from a 0 oxidation state to a +2, which means the zinc is being oxidized or serving as the reducing agent. So either B or C is correct. So then the question is, where is the oxidation taking place at? Well, oxidation is going to take place at the negative electrode because that's where zinc is giving up its electron and creating the negative charge. So D would be the correct answer. Number 8 says magnesium is higher in the reactivity series than zinc. In the cell shown, which direction do the electrons flow in the wire? That means they're going to flow from magnesium to zinc. So either B or C is, or B or D is my correct choice. And then it wants to know, is magnesium being oxidized or is zinc being oxidized? Since magnesium's the more reactive, it's going to be oxidized and give up the electrons. So D would be my correct choice. Question 9 says, what is the cell potential in V for the reaction that occurs when the following two half cells react? So in volts. So you've got Fe being reduced, and you have dichromate, it looks like perhaps being oxidized. And so what you do is you take your more positive value and you subtract the more negative value, which in this case is a negative value. And so that becomes 1.77, or C. With number 10, which statement is correct for the electrolysis of molten lead iodide? For electrolysis, chemical energy is converted to electrical energy. That would be just the opposite. Electrical energy is used to drive a chemical reaction. B says Pb2 plus ions are oxidized at the negative electrode. Well, Pb is going to be positive, so it would be attracted to the negative electrode, but they're going to gain electrons there to become Pb plus. So that would be reduction, not oxidation. C says I2 is produced at the positive electrode. Ib and I minus would go to the positive electrode. And in this case, that would be the anode because that is going to be oxidation occurring there. So C appears to be the correct choice. And then D says ions are produced at both electrodes, and that's not true. Ions are reduced at one and oxidized at the other. Number 11 says, in the electrolytic cell shown, at which electrode will chlorine form and what is the process taking place there? So this could be my positive electrode, this could be my negative electrode. So chlorine is going to be, chlorine has got a negative charge as an ion, so it's going to be attracted to the positive electrode. It's going to give up those electrons to become Cl2. So it's going to be at Q, and that's going to be oxidation that's occurring. Number 12 says the same quantity of electricity was passed through separate molten samples of sodium bromide and magnesium chloride. Which statement is true about the amount in moles that are formed? The amount of magnesium formed is equal to the amount of sodium formed. And that's not true because magnesium is going to need 2 electrons to every 1 electron that sodium needs. And if you're passing the same amount of electricity, the same number of electrons, more sodium should be forming. B says the amount of magnesium formed is equal to the amount of Cl2 formed. Well, magnesium is still going to need 2 electrons, but Cl2 is also going to be giving up 2 electrons because each chlorine will give up 1. So this appears to be a true statement. The amount of magnesium formed is twice the amount of Cl2. No, I believe it should be equal. And the amount of magnesium formed is twice the amount of Na. No, it's half the amount. They've got the ratio reversed there. So B is my best statement. Number 13, what happens at the negative electrode in a voltaic cell and in an electrolytic cell? So the negative electrode in a voltaic cell is where electrons are lost by the metal. So that's oxidation going on there. And in an electrolytic cell, it's where the positive ions come to get the electrons. So in a voltaic cell, we call that oxidation. In an electrolytic cell, that's reduction that's going on. Moving on to number 14 then, in some paper 2 questions. 14 says, define oxidation in terms of electron transfer. Quite simply, electrons are lost. That's what oxidation is. B says, chlorine can be made by reacting concentrated hydrochloric acid with potassium manganate. And then it wants to know what's the oxidation number of manganese in KMnO4. So the oxygen is going to be -2, potassium is going to be +1, so that means the manganese would have to be a +7 to have that be a neutral. Cl is going to be a -1, so manganese in this case will be a +2. And so number 2 says, deduce which species has been oxidized in this reaction and state the change in oxidation number that it has undergone. So if we look back, I'm going to go ahead and write the equation in here. We've got KMnO4 plus 16HCl becomes 2MnCl2. And we know this is going from +7 to +2, so the manganese is being reduced. We have 2KCl, 5Cl2, and 8H2O. So hydrogen and oxygen aren't under any conditions where they would be anything but their normal oxidation states. Same with potassium. So chlorine must be the other one. And so since we know that the manganese is being reduced, the chlorine is going to have to be oxidized. So it's a -1 here with the hydrogen. Over here it's still a -1 and a -1, but here it's a 0. So HCl is being oxidized to Cl2. And the change in oxidation number it's undergone is -1 to 0. Number 15 says fertilizers may cause health problems for babies because nitrates can change into nitrites in water used for drinking. Define oxidation number in terms of define oxidation in terms of oxidation numbers. So it's an oxidation number increases during oxidation, and deduce the oxidant states of nitrogen in the nitrate and nitrite ions. Well, in each case, oxygen is going to have its -2 charge. The ion is going to have a -1 charge. So in nitrate, it has a +5 charge, but in nitrite, it has a +3 charge. Number 16 says nitric acid reacts with silver in a redox reaction. Use oxidation numbers, deduce the complete balanced equation for the reaction showing all the reactants and products. And they've left me a couple blanks here because quite likely we're in an acidic solution. But I have silver at 0 and then a +1. I have oxygen at a -2 in each case, so my nitrogen is a +2, whereas over here it's a +5. So my silver is only giving up 1 electron, but my nitrogen needs 3, so I'm going to need 3 silver to provide enough electrons for the nitrogen. And then I don't have enough oxygen as written, so I'd need 2H2O here, which means I would need 4H plus here. And that should be my balanced equation. Let me just see if I can clean up that 4H plus so you can read what it says. I need 4 hydrogen ions to complete the equation. Number 17 says deduce the oxidation number of the nitrogen in the reactants and product. So my first product with nitrogen in it is NH3. So hydrogen will have a +1 oxidation state, so that means the nitrogen's a -3 oxidation state. The NO, I know that oxygen will have a -2, making nitrogen a +2. And in N2, the oxidation state will be 0. So part 2, deduce the oxidation and reduction half equations and identify the oxidizing agent for the reaction. NH3 is going to become N2, and that means I'm going to go from a -3 to a 0. So that would be 3 electrons, but since I'm forming N2, I'm going to need 2 NH3s for this to happen. So then I'd have a total of 6 electrons. I also need some hydrogen to balance that, so I would add 6H+. So that would be my half reaction for the oxidation going on. And then the NO is going to become N2. And again, I'll need 2 NO for this to happen. And since it's gaining, it's going from a +2 to a 0, it's gaining 2 electrons, or a total of 4 electrons in this case. And I'm going to need an H2O over here to balance it. Actually, 2 H2O, since I added a second one there. And so I'm also going to need 4 hydrogen on this side. So there's my half equation for the NO. And as far as the oxidizing agent is the species that's being reduced, so that would be my nitrogen monoxide. Part 3 of that question says 30 decimeters cubed of ammonia reacts with 30 decimeters cubed of nitrogen monoxide at 100 degrees. Identify which gas is in excess and by how much. Well, if I look at my balanced equation, it says 4 NH3 combines with 6 NO. And since these are both gases, if I have 30 of each, my NO is going to be my limiting reactant because it consumes more. So NH3 is in excess. And to find out how much, I can take the 30 liters times 4/6, because that's, I need 4 moles of NH3 to every 6 of the NO, and that means I will only use 20 liters of the 30 I have. So 20 liters of the NH3 will be used in the time that all 30 of this is used. So that means I have 10 liters left over. Part 1 wants us to draw a labeled diagram of a voltaic cell made from an iron half cell and a copper half cell. In your diagram, identify the positive electrode, the negative electrode, and the direction of electron flow in the external circuit. So I'm going to draw, this is going to be my iron ion. This is going to be my iron metal. Here's going to be my external wire to the other half cell, and that's going to contain my copper ion and my copper metal. I also need to include a salt bridge. And then I need to decide which way my electrons are flowing. So if I had a voltmeter, I would expect the electrons to flow from the iron to the copper. So that means oxidation is happening on the iron side, or the anode, and reduction is happening on the copper side, which would make that the cathode. Part 2 says deduce the half equations for the reactions taking place at the cathode and the anode. So if we start with the cathode first, I know at the cathode, that's the reduction, so Cu2 plus is gaining 2 electrons to form copper solid. I could include the aqueous here. Whereas at the anode, I've got iron being oxidized to iron ion with 2 electrons. Part 3 says deduce the overall equation for the reaction taking place in the voltaic cell and determine which species acts as the oxidizing agent and which species has been reduced. Well, the overall reaction is just going to be Fe plus copper 2 plus, I'm in trouble with my use here, is going to form iron 2 plus and copper metal. So this would be solid, aqueous, aqueous, and solid. And it's the copper 2 which is being reduced, making it the oxidizing agent. So I guess I wanted both. It's both reduced and the oxidizing agent. Number 19 then, switching up, we're going to look at an electrolytic cell. And it says, draw an electrolytic cell showing the electrolysis of molten nickel bromide. So I've got just one cell this time. I've got a power source leading to each electrode. So this being my positive electrode over here and my negative electrode on this side, the electrons are going to flow this way. I'm going to have nickel 2 plus and bromine minus in here. So I would expect the nickel to flow toward this, whereas the bromine will flow toward the positive. That means the bromine is going to be oxidized, so that would make this the anode over here. And the nickel is going to be reduced, making this the cathode on this side. So then they wanted to know the, include the electron flow, we've got that. The polarity of the electrodes, I've got that, and state the half equation. So the cathode, as I said, is going to be Ni 2 plus, gaining electrons to be reduced to nickel metal. Whereas at the anode, we're going to have bromine ion being oxidized to form bromine gas. So I'm going to need 2 on this side, and that means it's going to be giving up 2 electrons. Number 20, they want to know 2 differences between an electrolytic cell, so I'm just going to abbreviate that EC, and a voltaic cell. So one difference is an electrolytic cell uses electricity to drive redox, whereas with the voltaic cell, it uses redox to generate electricity. Electricity, if I can spell it there. Second difference is that in a voltaic cell, the anode is the negative end, but in an electrolytic cell, the anode is the positive electrode. Another difference is an electrolytic cell is just one cell, but this is 2 cells, 2 half cells to be exact. Another difference, an electrolytic cell needs a power source, whereas in a voltaic cell, it needs a salt bridge. They both need ions. They both need an external wire. Another difference is that electrolytic cell is a non-spontaneous or endothermic reaction, whereas a voltaic cell is a spontaneous or exothermic reaction. And those are the major differences. Which one's which here? Go back there.